Rakul, hope my presentation is visible now.
Yeah, it's visible now. You can go ahead.
Good morning, sir. Good morning, Rakul. So yeah. So this is the topic of my presentation. I would like to first introduce myself. I'm Harshavadni from final year Mech. The topic that I've chosen for Mech Talk 1 is next decade in mechanical engineering. So as the title itself says, my presentation will bring to you the recent trends in mechanical engineering. That is, what are the trends in mechanical engineering that's going to rule the world in the next 10 years, down the line next 10 years. So that is what my presentation is about. So with no further delay, I'll go to the agenda of my presentation. So my presentation is going to have slides which is going to explain next decade in mechanical engineering, but the first two slides will be about the introduction, that is what exactly is mechanical engineering and the ASME research study. So the other things are the recent trends that are going to rule the world in next 10 years. So here we come to the first slide, which has got the content in my presentation. I've added this slide because only if we know what exactly something does, we'll be able to know why we need it, right? So mechanical engineering, it is the discipline that applies the engineering principles to do four things in particular. Those four things are to design, analyze. Okay, once we've designed, we're going to analyze it if it would work out or not. And after analyzing, we will go for manufacturing the product or component or whatever it is. After manufacturing, is it okay if the component or part is on repair and we're not going to see the maintenance of it? No, that's not going to help us. So we're going to maintain the mechanical system. So these are the four main things that mechanical engineering does. So this is why mechanical engineering is so important. And if we look around, we'll not be able to point out one object in this world which which will be able to work without the aid of mechanical engineering. So that is why I've chosen this topic. So this slide brings you the reason why I've chosen this topic. Okay, so the next slide is about the ASME research study. ASME stands for American Society of Mechanical Engineers. Okay, so that ASME body has given a research study that in over the next 2 decades time, these will be the situation and the point of what an engineer will face. Okay, so the prestige of working as an engineer itself will increase. So the prestige will itself increase. The salaries, the financial rewards that an engineer is going to get will be greater than what it is now. So, number of engineers working in less developed countries. There are countries which are developed, which are under development, and which are in the state of development. And so, in less developed countries also, there will be greater chances of having more engineers than now. And engineers will have to communicate well in the upcoming years. That will be the criteria for the selection of engineers itself. And they'll also have to manage global teams. And yes, so the next line says skills in motion simulation. So first, let me explain what motion simulation is. So motion simulator or motion platform is a mechanism that creates the feeling of being in a real motion environment, but it's not actually a real motion environment. We're just creating a visual display of the outside world. We're just synchronizing it. Okay? So that is what motion simulation is about. Animation, as we all know, it's just the in which the figures are manipulated to appear as moving images. That is what animation. And virtual prototyping is the process of product development in which we validate a design before committing it to make a prototype. So eventually, it will reduce the cost. It will reduce time. Validate the design before we're making it to physical. Next decade in mechanical engineering. The first slide, next decade mechanical engineering, brings to you Hyperloop. So, as we all know, Hyperloop is an open source backtrend design. Means, I'll tell you how it works first, then we'll be able to understand these. It's actually got the tube or a system of tubes. We maintain the tubes in low pressure. Then what we do is, we have a pod there. We'll give a pressure, we maintain it in a low pressure. So what happens is, the pod will travel without friction. That will be free of air resistance. So the pod will, just like that, it will be like floating in air. We're going to make these hyperloops are now in particular in the hands of Tesla and SpaceX. They are in the idea of marketing it. About flying, but hydro flight, as the word itself explains, hydro flighting. So water and it flies. What is we supply propulsion to the drive. You see a boot-like thing at the bottom of the man, right? So that thing, we are going to supply propulsion to it. So what happens is the flyboard will fly into the air, and they're using it for sporting nowadays. That is used for hydroflying as a sport. So boots with it provides the thrust for the rider to fly, and the fact is that up to 22 meters feet at height with 2 meters. So that's it. Okay. So the next slide is about drones. So drones are just UAVs, unmanned aerial vehicles. UAVs, unmanned. So that's going to be an aircraft without a human pilot. Okay. So yes. So the most interesting fact here is it can work in about 2,000 meters away from its transmitter. As we all know, transmitter is or a radio transmitter is an electronic device which produces radio waves with an antenna, right? So even if the transmitter is about 2,000 meters away from the drones, it is still capable of working. In recent days, we have seen it during this COVID period. We have seen it in spraying sanitizers and all. So it's of great use now itself, and it's going to be useful in the upcoming years also. The next slide is about self-driving cars. Self-driving cars are also called autonomous vehicle, driverless car, robo car, or robotic car. So this vehicle is capable of sensing its environment, and it helps us to live safe or no human input at all. So it will need a very little human assistance, or to tell the fact, it will not at all need human assistance at all. For now, in India, the Road Transport and Highways Minister, Nitin Gadkari, has stated that self-driving cars are not allowed in India for now alone, as per the information from the government has come. It is just the extension of that slide, driverless car, Google self-driving car. So, here's the Lidar. Lidar is the method for measuring distance by illuminating the target with lasers. We have a target, and from this source point, we give out laser beams, it will hit the target and come back. So from this reflection, we'll be able to measure the distance. So this is the functionality of a Lidar. So I mentioned a word called Chauffeur system. Maybe that's a new term for it. I'll explain what Chauffeur system is. Chauffeur system is a person. Actually, it means a person employed to drive a passenger motor vehicle. So as we're taking the ideology of a chauffeur, they've given it as chauffeur system. That is what it means. And there is a company called Waymo LLC in American Autonomous Driving Technology. That's an driving technology development company, Autonomous Driving Technology. It is a subsidiary of Alphabet Inc. As we all know, it is the parent company of Google. So that app actually takes up the request of a pickup. And the fact is that it can work without safety backup drivers in the vehicle itself. So that is really a great accomplishment, I hope. So it works with the aid of Google Maps, and it contains 64 lasers, which eventually gives 360-degree control. And the cost is estimated to be 1 lakh, and the top speed is 40 kilometers per hour. TATA and ISRO's first hydrogen fuel cell bus in India. Okay, so let me explain what this is. This vehicle uses only hydrogen gas and oxygen to run on roads. But the important thing here is it gives only water and heat as a byproduct. Can you just imagine a world which is pollution free, because we have vehicles that can give only water and heat as byproduct? So that is named Zero-emission mass transport solution. It is now used in intercity commute. So this is about the hydrogen-powered star bus. So thinking about how this works, they're using hydrogen fuel cells that produce electricity by combining hydrogen and oxygen atoms. So this is how exactly it works. So in this slide also I'll be explaining the same concept but in detail. This is about the Toyota's first mass market fuel cell car, MIRAL. This converts hydrogen into electricity. So how does it do that? The same concept. It uses hydrogen fuel cells. So the hydrogen reacts with oxygen. In lower grades, we would have learned electrochemical cells, right? In that electrochemical cells, it is similar to that of a battery, which produces electricity. What it gives out, it's only water and a small amount of heat. So what do we need more than this from a vehicle that gives only water, emits only water drops, and not anything else that is of bad impact to the environment? So where are we using it? We are using it in forklifts, trucks, and buses. Slide is about Honda's self-balancing motorcycle. So what it does is it gives us with the help of the gyroscope. We have learned it in KOM and dynamics of machines. So gyroscope is a device used for measuring or maintaining orientation and angular velocity, right? But this Honda self-balancing motorcycle will be able to work without the use of gyroscopes itself. So this is going to give the riding assist, and it will balance itself in low speeds. So this is the main idea of Honda self-balancing motorcycle. So the next slide brings to you the first turbine-powered street legal motorcycle, MTT Y2K Superbike. So let me explain what this bike is. So MTT is actually a company, Turbine Technologies, MTT. It is a US turbine manufacturer in Franklin, Los Angeles actually. The company produces high performance turbines for boats and fire suppression pumps. So what it has done for this bike is It has created the most powerful street legal motorcycle in the world. It works with the help of the turbo shaft. So this is how this bike works. This motorcycle, uh, powered by a turbo shaft engine, was in practice since 2000 year. So these bikes are not mass produced. Um, each unique bike is handmade to order after receiving the buyer's specifications. Once the buyer specifies, like, I want it this way, I want it that way, I want according to these specifications, um, then only they take the order and they produce it. This is how it works. And more importantly, it is took part in the Guinness World Records, which considers it as the most expensive production motorcycle as of now. So this is the uh, thing about the first turbine-powered street legal motorcycle. The DEVEL 16 V16 hypercar is what we're going to see in the next slide. So this works on quad turbo technology. So we'd have learned it in previous automobile engineering or subjects related to that. We've learned about turbo or turbocharges. It is actually a compressor that forces air into the intake. This is done with the turbine that runs off the exhaust gases. Okay, so this is what we have learned about turbocharges. So uh, this uses quad turbo system, which is very similar to a parallel or a twin turbo system. So, but this takes a use of four turbos of the same size. So this is how this is mainly used for V12 or V16 engines. So they have the required exhaust flow from 3 or 4 cylinders. So this is the most powerful engine in the world itself, and it has got 12.3 liter V16. Generally, engines are measured by displacement, usually expressed in liters or cubic centimeters, cc's, right? So here they are mentioned in liters. So 12.3 liters of V16 engine. So this reaches PS. PS means 1 PS is equal to 0.98632 horsepower. So on calculating it, it gives us 0 to 60 PS. Okay. Yes, in that too in 1.8 seconds. Just imagine 1.8 seconds. So it is given a top speed of in the range of about 300 miles per hour to 480 um, miles per hour. So somewhere between these two. That's why they've given it as a top speeding near 350 miles per hour. So let me move on to the next slide of my presentation. It's about the Tesla's electric car. So as we all know, we've known it as Tesla Roadster. This has been into existence and ideologies from 2008 itself. So it uses lithium-ion batteries cells, and it uses AC motors. It has got an EV in the sense electric vehicles. I'm sorry, electric vehicles with a range greater than 200 mi. So mi here stands for miles. That is, I'm manipulating it. We get 320 kilometers per hour per charge. Okay. So this is how the Tesla electric cars work. As we all know, in down the line in some years, we're going to have only electric cars in existence, and which will throw all these um, older traditional methods of cars away. Yes. So the next slide is about the Tesla's battery storage. So the Powerwall and the Powerpack, which is actually stationary. That is not for now. It is not mobile. There are only stationary stations in which Tesla's battery storage is available. Those are rechargeable lithium-ion batteries. These lithium-ion batteries can be recharged again and again when they drain of energies. Yeah, so this is about the Tesla's battery storage. The next one is about 3D printing.
So 3D printing is an additive manufacturing technology in which we. So the next slide is about a 3D printed house. So this is a house in Shandong province in China. This is an ongoing product. Project. This saves 80% of the construction cost. And if you're asking about the if it can withstand the natural calamities and all, it is proved to withstand actually. So this is about the 3D printed house. Think about it. About 80% of the construction cost is reduced. This is about the next slide is about the autonomous robots. So these are also called share robots or uh, humanoid robots will be my next thing, but this is about the autonomous robot. It does its work on itself, so it works safely. It is of less cost, and it has got a greater range of capabilities. So this is about the autonomous robots. And the next slide brings to you artificial intelligence and humanoid robots. Nobody can deny the fact that this will have a great impact in our lives in the upcoming years. So humanoid robots, as we all know, Sophia, and there are so much robots that have come into existence now, and it is given its support to the human environment. So the next thing is about artificial and 3D printed skin advances for robots and humans. So it takes the help of sensors and microelectronics. So if somebody has got an wound or they've even lost a part of their body, this artificial and 3D printed skin can be imparted to themselves, and they can get their lost skin. It'll be a permanent replacement for their lost skin. So this is about the 3D printing to make human skin to cover wounds. So the next slide is about mesh and vision. So this is generally used in quality management area. It does its inspection automatically. It scans devices and sees if they are of right dimensions and quality. The next one is about coordinate measuring system, CMM. What it does is it measures the object or substance in every possible physical geometry in 3D as a 3D object. So this is used as in drafting machines nowadays. It converts the 3D object into a 2D data. So this is about the coordinate measuring system. So almost we're coming to the end of the presentation. So this is about the transparent wood composites. These are novel wood materials with 90% transparency. So in my slide, all the pictures that I wanted to show, I've had it as a background image. Um, so it's related to the content. The important aspect here is it has got higher mechanical properties than wood itself. So we should think about it, and it is also completely biodegradable with 90% transparency. So this is the unique property of this transparent wood composite. The next one is about the typhoon turbine. It harnesses the typhoons. That is, typhoons in Japan. That's kind of a storm, a hailstorm. No, we can't call it a hailstorm. That's actually cyclones. Okay, so these are used to run the turbines. By 2100, Japan will be able to harness about 60% of its energy needs only from this typhoon turbines. So this is being implemented in all the coasts in Japan now. So yeah, to the almost to the last of my presentation, self-healing machines. So we have always heard about airplane accidents because of bird striking. Once the bird strikes and the airplane comes to crash, it crashes. So this airplane, as you can see in the image, it can self-heal itself. It can fix its cracks. These are self-healing helmets. If you meet with an accident, it can heal itself. It is designed in such a way. So yes, we can never deny the fact that Industry 4.0 is going to have a great revolution in the upcoming years, as related to mechanical engineers as well. So these are my references. So yes, so we have come to the end of the presentation. Should you have any queries?
Actually, we have covered all the parts, all the upcoming things. So it's really nice to have an vision over that. So it's a collection gallery, I think.